Hey everybody, one more section on section 6.5, and it talks about the graphing of the inverse trigonometric functions. And so let's go back over and take a look at these inverse trigonometric functions for a moment. We had y equals inverse sine of x, y equals inverse cosine of x, and y equals inverse tangent of x. And if you recall in our definition, we had said that inverse sine of x is defined for values of x between -1 and +1, and y values between -π/2 and +π/2. So that being the case, what would the graph look like? Well, if we take the values from -1 to 1, that means that along our x-axis right here, we're talking about the y values, or the x values of -1 to +1 here. And at these endpoints right here, the y value that we get that corresponds to that is the angle π/2 here, and the angle -π/2 here. And again, it might be helpful to think about this as the graph of the sine of x just tilted on its side, right? And that's kind of what's happening right here. Of course, when you look at that sine graph, you can imagine is what would happen if there were more of it over here, let's say, going this way, or more of the sine graph going this way, right? But since we want to make it 1-to-1, that's the reason why it looks like it does. So let's get rid of the offending parts here because they're not actually there. Okay, so this is our graph of y equals inverse sine of x. Y equals inverse cosine of x, same domain, -1 to +1. And the range, we're going to go from 0 to pi this time. That means all the angles that we get from our inverse cosine function start at 0 and end at pi. If we're looking at the graph right here, that means that the graph comes down right here. It should actually come right down. And at x equals 1, and we're going to go as far to the left as x equals -1, our y values will range from 0 to pi. We'll pass through the origin here, through the y-axis at the point π/2, so 0 π/2 is on the graph right here, just like 0, 0 is on our graph over here. So our cosine basic function looks like this. Again, it might be helpful to visualize a sideways cosine graph going through these points. Finally, we have the inverse tangent graph. And the inverse tangent graph is one who has, we're looking at a graph that passes through the origin, and tangent would normally have vertical asymptotes at -π/2 and +π/2. So those are going to turn into horizontal asymptotes in our graphing right here. So this is the line y equals π/2 right here. This is the horizontal line y equals -π/2 down here. So if we're graphing any ideas right here for the tangent graph, our domain is all real numbers. Our range goes between -π/2 to +π/2 like it did for sine. The only difference is that the y values never actually attain π/2 and -π/2. They become horizontal asymptotes. So we would want to know that about our graph if we had to shift it somewhere. Okay, so given these values, given these parameters, how would we handle some of these graphs? Well, a good way of thinking about it here is to imagine that for the inverse sine and inverse cosine, we really are enclosing these particular values in a box. And I kind of think of the box this way. It's a box whose domain, -1 to 1, is its width, and whose height, top to bottom, is -π/2 to +π/2 in the natural function. Similarly for cosine, we go from 0 to pi height-wise, and we go from negative 1 to 1 with y's. And I'll show you what difference that makes as far as our graphing is concerned. Let's say we're told to sketch the graph of y equals negative 2 times the inverse sine of x. What does this negative 2 do it? Well, the negative 2 does two things. Number one, there's going to be a reflection of the original graph. And number two, there's going to be a stretch of the original graph. I'll deal with the stretch first. What the stretch does, if it's changed y equals negative 2 times the inverse sine of x, what we're saying is that whatever y values we might have had before, we're going to multiply those by 2. So the y values normally, without a stretch, would go negative pi over 2 to positive pi over 2. But what's going to happen is that the values for our function are going to go between twice that, negative 2 times those values. So we're going to go from negative 2 to 2 times that. So that means we're going to go from negative pi to positive pi. It's a stretch. It's a vertical stretch, right? So if this is pi over 2 right here, our graph is now going to go as high as pi. And if this is negative pi over 2 right here, we're going to double that, and we're going to go down as far as negative pi. The x values do not change. The x values stay between negative 1 and positive 1. We have not changed that, negative 1 to positive 1. So what's going to happen is that our graph, I'll make this one negative 1 right here. I'll make this positive 1 right here. And I'm going to have my graph look like this. So it would go from negative pi, negative 1, to 0 to 1 pi. And the graph would look kind of like a sideways piece of a sine graph with a stretch in the vertical direction. And again, for comparison, you can check out the graph of y equals inverse sine of x. I'll just dash that in right here. Here it is, right? Our graph of inverse sine of x would look like this. So it's a vertical stretch. Now, one other thing that we should pay attention to, and I did not, hopefully you didn't notice that too much, was the fact that it's a stretch, but it's also a reflection. So what happened with my reflection? Well, that was my stretch right there. Let me just go ahead and use my eraser a little bit right here. This one right here would have been my stretch, but now we're going to have to take that and we're going to reverse all of the y values that we would normally get. So what's going to actually happen is that our graph is going to go like this. It's going to go from, at negative 1, we're going to go up to positive pi because we're reflecting. We're going to go through 0, 0, and we're going to go through positive 1, negative pi. So in this case, we're just going to take that shape that we just had and we're going to reflect it down this way. And so our actual graph, y equals 2 sine of x, right here in purple, that's the one that we wanted. Not too bad, right? All that is just a stretch. All right, we can change the position of the graph as well. If there's a change in the position, the way the change in the position is going to work is that we're going to just simply shift, whether we're talking about a vertical shift or a horizontal shift. Well, in this case, this particular graph happens to be a vertical shift. And it's a vertical shift downward of 1. So how does that change things? Well, normally our y values would go between 0 and pi. Right? So 0 to pi. But we're adding negative 1 to that. So we're subtracting 1 from both ends right here. And so really, our y values, our range is going to go from negative 1 to pi minus 1. All right, so if we're looking at our graph right here, normally here would be, let's call this 0 right here. So we're going to go up to, here would be pi over 2. Okay. Here's pi over 2, and this one is going to be pi right here. So we'll call this pi. Right, here's 0. But our shift is going to be downward by 1. So that is about, let's see, let's call this about pi minus 1 right here. And so we're going to go down by 1. And here will be negative 1. All right, what happens there? Well, normally there's no reflection of the graph this time. Our x values stay between negative 1 and positive 1 in this particular case. And so we're going to go out to positive 1 along the x-axis. We're going to go out to negative 1 along the x-axis. And where normally our graph would pass through points like 1, 0, pi over 2, 1, negative 1 pi. Right here, I'll just dash this in really lightly. This is what our normal little cosine, inverse cosine graph would look like. We're shifting everything downward. So now our graph is going to go through negative 1, negative 1. It would pass through the y-axis at pi over 2 minus 1. Actually, I should put that probably right more like here. And it would pass through negative 1, pi minus 1. And so our new graph is nothing more than a downward shift of the old graph. So all of these kinds of shifts are things that you guys can handle. You've done them in the past. So good luck with your graphs this weekend.